Hi, this is Manuel, Delta Lima 2, Mike Alpha November. Welcome back to my channel. At this point in time, I actually wanted to present you my next video about the NFET half-wave transformer, but yeah, you might be able to hear it. COVID got me. I'm now at the end of a 1-week journey through that virus infection. So I didn't manage to do everything I wanted to do. So instead of now presenting you the results, I'm taking you with me on the journey, how we are going to figure out what works and what not. So basically this is about me trying new stuff, me testing stuff, me trying to narrow down what's going on here. So join me on that journey. So step number 1 is to find a spot, which is where I am, where I can elevate the antenna a real wire and actually do different tests with it. So I need a pretty open spot. I'm going to use David's pole holder. This is my new car. I'm going to drive on it, and so we can elevate the antenna. And by the way, please excuse the fact that I'm even more or easier to get out of breath than usual. It's still the rest of the COVID. Yeah, that's perfect. This is a very easy way to elevate an antenna. When you can get there with your car, you can very easy elevate it. So this is the same antenna I got with me when I was doing the activation of Castle Hohenburg, the one with the bad SWR. And this is why I brought it again. I wanted to do some additional measurements. I will show you later. Now let's elevate the antenna. By the way, I got to mention, everything here is full of sheep shit. You gotta really be careful where to step. This is the middle point. So step 1 is obviously always laying the antenna to the ground to get a rough estimate from where to where the antenna is going. Then looking for the middle point, there it is. Put it to the pole, attach it to the pole, elevate it. I'm not sure if I'm still in the picture, but one thing I really like about this antenna is that you don't need too much space. I didn't choose wisely. If I cannot get those stakes into the ground. Let's see. Okay, but everything's accessible. The thing is, I'm going to put a little bit more pressure on here. Yeah, let's try. Okay, we'll have a look at how the antenna performs over real ground with the 1 in 49 transformer I prepared with the double cores. Just get the right adapter here. There seems to be some kind of ground issue. I'm now saving the curve just so that you can see what I see. What I can see now, that's S1, curve 1 stored, without touching it. Now I'm doing the same thing with touching it. I'm saving the same curve, curve 2. SWR is changing a little bit. I can still see that, yeah, well, what is it? Marker. I'm seeing SWR of 3 at 7.2 megahertz. That's not too good. Lowest SWR is around about 6.915 megahertz with 2.1 to 2.5, 1 to 2.15, sorry. 14 megahertz looks decently, like 1.4, and 28 is also good, 1.27. The reason I'm here today is because I wanted to figure out whether this fundamental SWR is dependent on the impedance transformation ratio. So what I brought here today is a experimental transformer that I want to put there instead of the transformer we already have there, and then tapping different impedance transformation ratios and see how that changes the SWR on the fundamental. Maybe we can get away with something or stay at least as flexible as we can when we try to set up this thing on different locations, because obviously it does make a difference if you put that thing up 4 meters in the air, or like in my case now 7 or 8 meters. This makes a huge difference. I'm going to show you that later, but let's try this one first. So what I'm going to do now, I'm trying to somehow put this thing here in place. Just add it here. Hang it here. I know it will probably hang a little bit. It will pull down a little bit more. Let's see. Yeah, doesn't matter. We will be able to see what we need to see. So I just added that experimental transformer to my real one. Okay, now what I'm going to do is I'm going to pull the plug here, put it to this transformer. Now let's repeat the measurement with the 1 in 49 point of the other transformer, so we have a direct comparison. One in 49 point. Okay, so you can see it already changed the SWR in the upper portion of the band. I'm now going to go through all the SWR transformation, all the taps I made here to see whether this changes something. So I'm starting at the lowest point. I think this is 1250 ohms now. Yeah. Now SWR on 40 meters even worse. That's curve number 4. Next point. This is 1 in 6 squared, so 1 in 36. Save that. Repeating measurement, 1 in 7 squared, which is 1 in 49. Now, for the interesting part, now using even higher impedance transformation. In this case, it's 1 in 8 squared, so 1 in 64. And, look at that. The dip is going lower while the fundamental frequency is a little bit off. Now I'm going even 1 in 9 squared, which is 1 in 81 impedance transformation. Sorry, 1 in 81 impedance transformation, yes. And it's getting even lower. This is curve number 8. So by changing the impedance transformation ratio, I could clearly see that SWR of fundamental can be affected. While in 1 in 49, it was clearly visible that we could not reach 1 in 1 SWR, and now I'm as ridiculously high as 1 in 81, and you could see the SWR on the fundamental is low, so this is an impedance transformation thing. With this transformer, we are not transforming to the right impedance that is necessary for this antenna in this elevation. Interesting. I was hoping to figure that out, but I was not sure, so here we are. Now, the next thing I'm going to try is... what's the next thing I'm going to try? I think I'm going to use the original transformer, switch it to 30 meters, put the pole down. No, show it to you like it is now in the 8 meter elevation. Then I'm going to put it down, reset the antenna, and showing the SWR then again, because it's interesting. The proximity to the ground changes everything for those types of antennas. This is what you gotta have in mind. I had a discussion with David when we were in Belgium, and he had that NFET half-wave you all saw us use. And he was claiming that this thing is, because of his, I think it was, he thought it was because of his transformer and the way he wound it, that it could be used on virtually any band with good SWR. And what I figured out with those experiments here is that actually it is the proximity to the ground that makes SWR good. What I could see from the SWR measurement, from the nano VNA measurement, when I put this thing on 4 meters of elevation, that the 30 meter antenna, even though it should not be, was resonant completely on 80 and 60 meters. I'm going to check that now, and I'm going to confirm that with the actual transceiver, if we can actually use it down there. The question still remains, how effective is it? But just test, confirm, you know. Curve number 9 is now the 10 megahertz 30 meter section active in 8 meters of elevation. Now what I'm going to do is I'm going to put it down to around about 4 meters. I'm going to make the rope tensioners straight and flat again, and then we are going to repeat that very same measurement. So now we are effectively closer to the ground. Yeah, I thought so. I cannot repeat this effect I saw at home. Going to save the curve now for the same antenna in lower altitude. Okay, so that was a dead end. Yeah, I need to think about what we just saw and then try to come up with a summary in the end. The other thing I wanted to try and I want to show you today is a different pole setup. I'm going to show you now. So you remember the video at Lauterachtal and Burg Hohenburg, where I got this pole, which is pretty good, but I needed to put it on the outside of my backpack in order to be able to transport it, and this made me visible for everyone. Everybody knew that there was something going on that is not going on usually. So I went Alibaba shopping, AliExpress shopping, and I bought this fishing pole here. This is supposed to be 6 meters and 30 centimeters in length, which is not true. I will tell you straight away. I measured around about 5 meters and 80 centimeters, like half a meter shorter than it's supposed to be. And I needed to remove the smallest elements, otherwise it would not be able to carry the antenna. But this is a really small setup, like 44 centimeters in length when not elevated. I 3D printed some parts and I'm trying to elevate this very antenna with this pole, like minimum setup you can carry in your backpack and be completely disguised or flying under the radar, let's say. I'm not sure if this works, if my idea works. I'm going to try that right here. You will be live with me, or not live, but you will see that with me as I'm failing or succeeding. Not sure where I'm going to do this. It's probably best to have a little bit of soil underneath me, so I'm going to do that behind the camera. I'm going to turn around the camera and set up the antenna there. Great. Because this is going to be the minimum setup, the absolute minimum setup. Yeah, I needed to figure out a way to elevate this thing without too much additional going on. I didn't want to have guy line support here. So what I thought of is just elevate the antenna in shape of an inverted V, narrow down the horizontal plane angle a little bit more, so with just one string we can have a 3-leg setup here. I'm not sure what's necessary to do this. I'm going to attach the antenna with this carabiner of that rope, that guy line. I'm using that same carabiner. Now elevating the antenna first. Ugh. See, this is why you don't buy Chinese cheap stuff. I'm not sure if this will hold up, to be honest with you. That's a cheap fishing pole, like 18 bucks. Not too confident, but hey, let's try it. Yeah, okay. So we are fixed now. The last thing I'm going to do, so I'm going to elevate the pole, put it under tension. Hopefully the let back was enough, so we can elevate that thing. Now let's look for some tension here. Yeah, yeah, tension, tension. Okay, Look at this. It works. It's not how it's supposed to look like. Nope. It's not how it's supposed to look like. So this is actually also a fail. I mean, we can use that opportunity to measure how an antenna in this low altitude behaves. Maybe we can see what I wanted to see initially. Oh shit. I stepped into sheep poop. Great. Okay. Going to save this curve now. Curve 11 saved. Okay, then let's pack up. Let me think about it and give you the wrap up in the end. Okay guys, before I tell you what I think of it, please let me know in the comments what you think of the results today. I think it was pretty mixed. While the fishing pole was a complete fail, it cannot carry even a very lightweight antenna like I used today. Maybe I will need to come up with either a more lightweight solution or add a different support system to that thing. I mean, it's not over yet, but not too satisfied, but I didn't expect too much, to be honest with you. Regarding the results of the NFET, I think we could see and prove that by just changing the translation ratio, the transformation ratio of the NFET half-wave transformer, the broadband transformer, you could lower down the SWR of the fundamental. That was the main takeaway for me today. So in order to use such an NFET over the whole amount of bands that it's supposed to use, in my case it was a 40, 20, 15, 10, and I had a plug for 30 meters in there. But I realized that the 40 meter SWR low point was actually pretty high. That's what I could see at my activation. And by increasing the impedance transformation ratio, I could bring that further down. However, if you look at the curve again and compare that, just skip back in the video, you can see that when the fundamental is very low in SWR, the higher bands are not. So this means we need to be able to somehow adjust the transformation ratio while outdoors. That is what I would think of it. This is why I used the tabs. I didn't do too much experiments for now with different winding patterns. I tried 2 or 3 and couldn't see too much of a difference. I'm not sure if I will do another video about that. I would really love to know what you think about what we saw today. If there's any other explanations I might not have seen or any suggestions, I would really love to get your feedback about that, because this is, well, you saw me exploring that on the go. So interpreting the results, I leave it up to you. I would really love to get your feedback about that. Thanks anyway for watching, and I see you next time. 73, bye bye.